my restaurant, Kaminsky's, hasn't been doing too good lately. For 8 p.m., my love. I need a new recipe.
I mean, like, I don't even know. Maybe we should just do, like, donuts or something. Like, Krispy Kreme is down the road. We can just go look.
Oh, my darling. This is why I love you. Oh, but only if I knew the volume of it. I need to know how much frosting was used, and how big the donut is so I can make a pan.
I mean, like, don't even worry about it. Maybe we can just, like, take this ruler and go measure it out.
Oh, we made it to the Krispy Kreme!
Yeah, you know, we just up in here to Krispy Kreme.
We made it!
Bring it back.
Ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
Only if I knew how to use my calculus. Only if we could go back to those days.
Okay, so basically the problem in this FRQ is that two chefs, aka me and Renithia in the future, want to mimic Krispy Kreme donuts. So basically they go and they take some measurements, and the two things that they want to find is the volume of the actual donut and then the volume of the icing that is on top of the donut, which is only on the upper half of the donut. So the cross section of the donut is actually a perfect circle, and the measurements that were given is that the donut's diameter is 3.5 inches, the width from the inner of the hole to the edge is 1.4 inches, the height is 0.7 inches, and the glazed depth is 0.1 inches. So from that, because we know that the height is 0.7 inches, we know that the radius is 0.7 inches. And basically, we can look at it too. The width from the edge to the hole is also 1.4. You divide that by 2 and you get 0.7. So that's the radius in this problem. So part A is basically asking for you to write an equation of the circle so that the center of the hole is centered at the origin. So we know that from the center of the hole to the edge of the donut is going to be 3.5 divided by 2, which ends up being 1.75. So we know that we have this like length, and all of it's going to be 1.75. From the center to the edge is going to be 0.35. And the way that we find that is because we know that the width from the edge to the outer edge is going to be 1.4, because it's going to be 2 of the radius. So you just subtract 1.75 minus 1.4, and you get 0.35. And so basically this is just the general setup, and it's just going to help you kind of like navigate this problem and write the actual equation. So we felt like it was really important to like go through that. But the general equation for a circle is going to be r squared, which is your radius. You're going to have x minus h squared plus y minus, you can do like k squared. It really doesn't matter what value you use for that constant. But h and k basically represent where your center is oriented. So h will represent where it's oriented on the x-axis, y will represent where it's oriented on the y-axis. So basically from here, all we have to do is plug in our information. So you have 0.7 squared, and that's going to be equal to x minus, and so now we want to get to that center of the actual donut, so you're going to do 0.35 plus 0.7, and with that you get 1.05. You're going to square that plus y, and so this donut's going to be centered on the x-axis, so that's just going to be y, and you're going to square that. And so the second part of part A basically just asks you to graph this equation. So what this is going to look like is basically just going to be a circle some bit away from the y-axis, which is really important to consider with the second part of the question. So part B of this problem is actually asking you to find the volume of the Krispy Kreme donut. Perhaps like the chefs are trying to like make a pan or something. But basically a step that I didn't decide to show. But basically we're just going to convert this circular formula in terms of x, we're going to solve it for y, just so that we can use it in integration really easily. But basically what we're going to be doing is we're going to be rotating this function of x about the y-axis, because if you think about it, as you rotate that circle about the y-axis, it's going to make a donut shape with a hole in the center. So what we're going to be using in this case is going to be the shell method, and the reason that we're going to be using this is because we're going about the y-axis, but our equation is in terms of x. So shell method allows us to rotate about y while being in terms of x, which is something that's really helpful. So basically, the volume of this donut, shell method is going to be 2 pi times the integral of the x bounds. So basically what you're going to be looking at is 0.35, because that's the distance from the donut hole to the edge of the donut, to the outer edge of the donut, which is going to be 1.75. And we know that that's 1.75 because if you divide the total diameter of the donut, which is 3.5, that's what you get. So with shell method, you're going to do x times the actual function. So for this, we're going to be looking at just the positive version of this circular solved equation, and then we'll multiply by 2 to get the actual area, or the actual volume, because you can't look at both at once. So we're just going to write that in. Dx, because we are rotating about the y-axis in shell method, so that is dx. Because this is a calculator problem, this is a really complicated integral, we're just going to plug it into the calculator, and when you do that, you're going to get 5.07791. So the actual value of this is 5.07791, and then we're going to multiply that by 2 to get the area, or the volume of the whole donut, and when you do that, you're going to get 10.1558. Something that's really important when you're doing AP FRQs is to include the units if they're given. So in this instant, it's in inches. So what we're going to want to do is inches cubed because this is volume. So the second part of the FRQ basically asks you to find the volume of glaze that is used on this donut, assuming that the glaze is only applied to the top half of the donut. So if you cut it like a bagel, it would be like the top half of the bagel, given that the glaze depth is 0.1 inches. So you might look at this and you might think, oh, like I want to do surface area, but the only issue that comes about is because you are rotating about the y-axis, if you want to find a surface area, you're going to have your equation in terms of y, which is just a lot of work because it is like shifted on the x. So what we decided to do was kind of look at it in a different way and rewrite the circle equation kind of so that it fits that 0.1 inches that are added. So the way that we do this, also this is part C, we're going to say y is equal to 0.8, because if you think about it, that 0.1 is just going to add on to the radius. It's not going to change the center or anything. So we're going to have 0.8 squared minus x minus 1.05 squared and the square root of that. So basically what we're going to do from here is basically repeat what we did in part B and find the volume of this donut with glaze. So to do this, it's just really important to note that, again, we are going to be using the shell method, but something to take note of when you do start the shell method for this part is that your bounds are going to be changing. And so basically because you're adding that 0.1 inches to both sides, your left bound is going to be subtracted by 0.1, so you're going to get 0.25. And then your right bound is going to have 0.1 added to it, so you're going to have 1.85. And then basically what you're going to do is you're just going to complete shell method again. So you're going to have x times this function that we just derived. So we're going to plug that in. It's 0.8 squared minus x minus 1.05 squared. And then once again, because this is shell method, it's going to be dx because we're rotating about the y-axis. So when you plug this into the calculator, you're going to get 6.63237. And that is inches cubed. And so the specific problem is basically asking for the volume of the actual icing. So the way that you can figure that out is by looking at the volume of the upper half of the donut with icing on it versus the volume of the upper half of the donut without icing on it. So basically, if you were to look at this on the graph, this outer semicircle would kind of represent the donut with the icing on it. Obviously, it's kind of exaggerated. And then the inner circle will represent the donut without icing on it. So if you actually subtract those two volumes, the volume that you'll get is the volume that was added, which is of the icing. So to do that, we're going to say the volume of the icing, so V sub I, is going to be equal to the volume of the upper half of the donut with icing on it. So that's 6.632 minus the upper half of the donut without icing on it, which is 5.077. And when you do that, the number that you get is 1.55446. So you have 1.55446, and that is going to be in inches cubed because we're working in inches. And that is the exact volume of the icing that is added to the Krispy Kreme donuts.
Is it good?
Let me back up.